All right, so that leads us to the official listing of steps for the chi-square test of independence. Right here it says determine the null and alternative hypotheses, which is very simple. It's always the row and column variable are independent and the row and column variable are dependent. You just have to list out what the row and column variables are, all this other stuff. And you get to assumptions right here. Just like with the test for goodness of fit, you need all your expected counts to be greater than or equal to 1. No more than 20% of the counts are less than 5. Same formula for the test statistic is just going to be a little bit harder to calculate. The degrees of freedom is a little bit different here. It's r minus 1 times c minus 1, where r is the number of rows, c is the number of columns. And this is always a right-tailed test, no matter what. Okay, so let's do it. We're going to conduct a hypothesis test for the particular problem we were working on. So let's start with step 1. The null and alternative hypothesis. This would be money and income, or excuse me, money and income. Income and happiness are independent. The alternative to that is that they're not, right? Income and happiness are not independent, i.e. they're dependent. Okay, so there's your null and alternative. Step 2, very simple. Your alpha is given to you, so that's no problem. Oops. Okay, step 3. You've got your lovely chi-square statistic. You are going to find it with Excel, I would imagine. Nobody wants to find that stuff by hand. Okay, so let's go over here. Let's make a note of what it is. So if you were doing this with Excel, you could say, okay, here's step 3. And I just want to put it up here what the chi-square statistic is. Now, it's going to be kind of yucky to find, but we can do it. We need the observed minus the expected divided by the expected, and we need it for every one of these categories. There's a lot of them. So I'm going to go down here. Oops, I'm going to insert. Again, I'm moving that conditional distribution down. I don't really need it. Okay, now I want this is going to be to find the test statistic. Yes, I know there are actually more ways to do this, but bear with me here. Okay, so to find the test statistic, I'm going to find the observed minus the expected. Okay, so equals observed. I observed 21 minus the expected value, which was 35.77. If they had been independent, and I got to put that in parentheses, and I got to square it. And then I have to divide it by that expected value of 35.77. Enter. And just for the record, notice that none of our expected values are lower than 5, right? Which is good. Now I'm just going to drag this over, and it'll fill in all the rest of them. So for example, look, it did 110, take away 88, squared it, and divided by 88. All right, then I can take that row that I just filled out, and I can, oopsie, down the column. There we go. Okay, so now to find the test statistic, I don't really need all of this stuff. All I need is the sum of all these numbers. Okay, so the test statistic is equal to the sum of this whole shebang. There we go. It's 73.352. Right there. Okay, so I'm going to go back to my lovely formula here, and I'm just going to say that that was equal to, oops, 73.352. Test statistic done. All right, next I'm going to need step 4, but I'm going to do it both ways because that's just how I am. So I'm going to find both the classical and the p-value way. So the classical way is kind of interesting because you're going to need to find your degrees of freedom first. So let's go back here and look. Your degrees of freedom is equal to the number of rows you have minus 1 times the number of columns you have. If you look, you have 3 rows and 3 columns. So it's going to be 3 minus 1 times 3 minus 1.